I work with a research group that is funded by the National Institutes of Health to do simulations of biomolecular systems, so proteins, DNA, their lipid and aqueous environments. And we use some of the largest supercomputers available to do this, and we've been running on supercomputers for approximately 10 years now. We had been looking at different accelerator options for our code, nmd, before that, including FPGAs and GPUs and various other technologies. When I saw the CUDA technology at the show, I basically said in my head, okay, this is the way we're going to be able to program these things. It was going to be a mainstream consumer technology that had a good economic driver with a commodity base, and it was a good programming system. I could look at this, I could understand, oh, this is what I have to do to get performance, this is how the hardware is going to work with it, this is how I decompose things. Based on C, it was one of those things where someone tells you how to do it, and then it's just looking in the manual to see what the names of the special functions are, but there was nothing that was a big barrier to being able to actually write code. My office mate, John Stone, had been very skeptical over the years over the other technologies, and I said, I told him, this thing CUDA looks pretty cool, so yeah, whatever. Well, back in Urbana in January, I was coming into work, and I came across David Kirk, the chief scientist of NVIDIA, in the parking garage, and he was walking with Wenmei Wu, one of our ECE professors, to teach a class on programming GPUs. And I asked, can I sit in? She said, sure. Can I bring my office mate around? Sure. So I told John, you should come sit in on this class. Well, by the end of the class, John was actually giving a guest lecture on the first application that he had done, which had actually transformed the science that we could do, because they were trying to do the first simulation of a virus, and to prepare the data involved placing ions around the DNA and the virus, and doing that on the supercomputer would have required a lot of resources. You have to wait in the queue. They were able to get, I believe, on the order of 100x speed up doing this on the GPU on a single workstation. So that was sort of our first big success with CUDA that told us, okay, we really have something here.